In this video, we'll explore the various interfaces available to us to interact with AWS resources. The first thing that users are most familiar with is probably the web console. There's also an AWS API, as well as SDKs for programmatic access via most of the popular languages and platforms. There's also a swath of third-party products, including an Eclipse plugin, S3 browsers such as Cloudberry, and browser extensions for Chrome and Firefox, while Elastic and RightScale also offer deeper integrations. Probably the biggest drawback about the web console is that not all the features and services are supported. I'm guesstimating that it's probably missing about 30 to 50% of all overall functionality. It can be a little wonky. For example, it doesn't really like IE, and hey, to be honest, I don't either. It also often reports stale information. It is, however, excellent for managing most aspects of EC2 as well as S3. The access to the web console is controlled via username-password combination. The API comes in two flavors. The most popular is the REST API, but there's also a SOAP API that's mainly legacy. AWS is phasing out support of this. The REST API is done via request response over HTTP. It requires access and secret keys. It supports 100% of all the services and features available in AWS. Command line tools also wrap the REST API calls into Linux-like commands, such as this, to spin up a single instance. Each service has its own set of CLI tools, and you can download those through the AWS interface. The first three characters of each tool generally designates what it's for, such as EC2- is for EC2, AS- is for autoscaling, Mon- is for CloudWatch, so on and so forth. You can use the REST API in server-side bash scripts to programmatically control resources. For example, you could spin up assets at a certain time of day simply by firing off an API call. When dealing with eventually consistent resources, such as S3 and SQS, or those that live in the region, be particularly careful. You may write and then read and not see the data, or you may delete and then still see the data. The SOAP API does request response via XML documents. The interface to deal with the SOAP API is described by a WSDL document. It also requires creation and use of X509 certificates to sign the requests. AWS is phasing out support of this. Unless you have a very good reason, try to use the REST API or SDK for programmatic interface. The SDK provides native classes, objects, and so forth for specific server-side languages, such as Java, PHP, .NET, and so forth. It also provides mobile platform integration for Android and iOS, and there's new features and languages being added all the time. Service and feature support varies greatly language to language. Here's an SDK example in PHP of creating a new instance. Up here at the top, you can see that we require the SDK. We set up some parameters for it. We instantiate a new instance of an EC2 object in this case, and then we simply call a method called runInstances, passing in the variables that we described before. For developers, I also highly recommend the Eclipse plugin. It supports 10 services such as EC2, S3, SQS, DynamoDB, and so forth. For interface security, the APIs and console can both be locked down to specific actions or verbs such as create, and for specific nouns or resources for only some services, such as an S3 bucket named customer upload. Let's actually look at this in action. Using IAM, we're going to create a DB admin users group, which only has access to databases. From the top level, let's click IAM, and let's first create a group. Let's call this group DB admins. Let's use the policy generator to create a group with a specific set of permissions for database access. Let's give them full access to DynamoDB, full access to SimpleDB, full access to RDS, and let's maybe let them see EC2 instances by giving them access to describe instances. And let's select continue. This all looks good, so let's let it roll. Let's also add a user to this group named John Smith. Let's download our credentials for our user and make sure that we know where those got saved. Right here. And let's go into our users. Let's create a password for John Smith. And we'll create an auto-generated one and download this password as well. And let's actually copy this so we can log in as John Smith. I'm going to paste that there for later. Now let's log out of the interface and log back in as John Smith. When accessing AWS via IAM, we need to use a specific URL. Let's go to the dashboard and browse down to find this link. And let's copy that into a new browser. Now that we're ready to log in as John Smith, our DB admin user, let's go ahead and log out of our current account. Let's now log in via the IAM provided AWS login. And paste in the password that was created. Now it looks like John can access all kinds of stuff, but let's actually see what he can really access. We didn't give him permissions for Elastic MapReduce, and we see that he doesn't have permissions. We did give read-only permissions on EC2. Let's see what that gives us. And it does actually let us see the running instances. And now let's look at DynamoDB, to which John should have full access. It appears he does. And now let's look at RDS. And John definitely has access to everything there as well. Let's go ahead and log John Smith out. Not only the Web GUI, but the API calls as well would be locked down to the permissions that we gave to John Smith. Let's review what each interface is good for. The Web Console is great for quick and dirty eyeballing or control of resources. The REST API is the best for advanced use and automated interactions. The Eclipse plugin is great for developers, is a lot peppier or faster reacting than the Web Console, and provides a decent coverage of services and features. Third-party products are great for non-savvy users, or if you already use Elastic or RightScale.